All right, what are we going to talk about today? Well, we'll be talking about machine identities. We'll talk about how they're outpacing human identities. We'll talk about why you don't need to be scared of those machine identities that are out there, and give you some best practices on how to manage these machine identities in your organization today. Let's jump in. Well, hey everyone, this is Ryan Yackel with Key Factor, and today we're talking about an important topic today, which is what is machine identity management. We're not going to just talk about what machine identity management is. We're also going to be talking about some of the trends in machine identity management, and also give you kind of a little bit of a roadmap and how you can tackle some of these machine identity management challenges in your organization today. So, okay, let's start off. Like, what is machine identity management? We have to first talk about what is a machine identity, and a lot of times this might be a little scary for people to see. We've got Halloween coming around the corner here. But a lot of times when people think about machine identities, they think about maybe this nefarious skeleton-looking machine, Terminator-looking thing that's really, really bad, right? Well, and if you're trying to explain machine identities, people sometimes, they may think of it this way with all the stuff that's going on. And I know the Matrix is coming out with the Matrix 4 is coming out soon. So all these skeptical things about what is a machine identity. Well, machine identity is actually pretty simple. And it's not a nefarious thing that we need to really talk about today. So let's talk about what it is. So the first way to understand what machine identities are is to get a good idea of what human identities are. So human identities, if you look at kind of where we've been focusing on identity and access management and kind of where the focus has been on securing certain identities, it's really been focused on the human side. It's really focused on workforce identity, customer identity, usernames, passwords, things like that. And that's where you're getting a lot of investment from places like in SSO and multi-factor and PAM and all these things that are going on in the human identity space has really been a central strategy for IAM. That's been a big focus, right? However, even though there's lots of investment that's been going in this human identity side, there's also a way more number of machine identities that are out there when you compare those to human identities. So if a human identity is something like a username and a password, what would a machine identity be? Well, it could be things like workloads. This could be something like you have a container that you're using Kubernetes on and you're creating applications very quickly in the cloud. You're using RPA bots to put into your production environment to speed up repetitive processes. You're using microservices. Those can be all on the workload side. But then if you think about IoT and all the devices that are out there, all of those things that are out there, they also have these identities. Right now I'm using a microphone that is hopefully is encrypted with something that has something on it that could be encrypted with something, but it's a machine identity, right? Just like a laptop or a mouse or anything you're using, even in your car or wind turbine. All these types of things also are machines that require these identities. And we know that these identities are vastly outnumber the number of human identities. If you think about in your particular workforce you have today, you have all these things that are beyond just a standard laptop. So big thing to take away from here is that machine identities, again, are growing at a way faster rate than human identities. But there's also different types of machine identities. One of the ones that we talk about a lot is SSL and TLS certificates. This is a type of cryptography that goes into things like web servers and public websites. And you can actually go and look and find out one of these to find out what an identity looks like just by going to the top of your browser and clicking on that little lock icon. And that lock icon will tell you, hey, there's a certificate that's either valid or not valid. If it's not valid, it'll tell you, hey, be wary of this. You've got, this is not something that's publicly trusted yet. But then if you click into the valid certificate, you can see that in this particular instance, we have an issuer that's from Amazon that issued a SSL TLS certificate to make sure that this machine is publicly trusted with asymmetric cryptography with a digital certificate. And so if you think about all these public certificates that are out there, all the things that go on the web, on the internet require these types of certificates to ensure that identity, which is that website, to ensure that machine identity is secure and it can have these cross communications between other identities. However, there's lots of other machine identities that are actually out there. So we talked about SSL and TLS, but there's other things like SSH keys that are used for backend systems and processes. There's cryptographic and symmetric keys are used to protect data at rest in the cloud or on premise. There's code sign certificates that are used in more DevOps environments to make sure that the code that you are submitting and working with other developers is actually the code that you are signing and is secure code to be pushed into production. And then you have other things like secrets management and non-human identities that are also factor into this equation. So there's all these different types of not only physical and software related machine identities, but there are also different identities that use different cryptography to secure these. So keep that in mind. It gets very, very complex when you think about it, right? So we say all that to say, okay, that's great, but how then, if we know what a machine identity is, how do we actually manage machine identity management, and what is machine identity management? Well, in a simplistic form, you're talking about, hey, we want to make sure that we can manage all of these, right? Say, thanks, Ryan, no doubt. Well, let's get to a more specific term here. This profile, if you look at Gartner, this profile of machine identity management was actually created back in 2020 of the hype cycle for IAM strategy. And this is what they say. It's a new profile that reflects an increased need to manage cryptographic keys, X509 certificates, and other credentials to establish trust in identities machines such as IoT devices, virtual machines, containers, and RPA bots. So this quote that I just said ties into a lot of things I just mentioned previously on their slides. You have this increased need of different types of cryptographic assets, whether they're keys, certs, or credentials, and they're placed on different things like IoT devices, virtual machines, containers, RPA bots. We need to make sure that we are managing all of this, and the increased need to manage it is reflective of the increased velocity and volume of these machine identities that are out there. And to give an idea of how fast this machine identity management space is moving, if you look back in 2020, that's when Gartner recognized this as an official profile. It's a high priority for IAM strategy and success, right? But if you fast forward to today, which is around 2021 when this video was created, you see that it was one of the top security and risk trends for 2021. So within a year and a half, you have it being listed as a high priority for IAM strategy in the hype cycle. And then it's actually recommended as one of the top areas to focus on for 2021. And this is what they say. There's a lot of, again, it goes back to as the number of devices increases and continues to grow, you have to basically establish an enterprise-wide strategy for managing these machine identities to better secure your digital transformation. So the way this works, and Gartner does a really good job of describing this, the reason why they're hyper-focusing on having machine identity management in the IAM hype cycle, which is there in 2020 and also in 2021, and also recommended as trends, is the fact that you have this digital transformation that's going on. And I know everyone likes to say digital transformation. It's kind of a buzzword, but if you just follow the steps here, you're building all these digital things. How do you ensure that all the things we talked about, whether it's workloads or actual devices, how do you make sure that when you're creating these things, that they're talking to one another in a secure way and they're creating digital trust? The only way you can do that is by using different types of machine identities and cryptographic assets to actually control these. So that's a way that to kind of understand. If you look at digital transformation, it's got to have digital trust. How do you do that? We use cryptography to do that. You got to start managing machine identities. Okay, so let's talk about some of the challenges though. And so we walked through what is a machine identity, what's the management of it, and kind of formal and informal terms. Now let's talk about what are some of the challenges. And we actually, Key Factor and Pwnymon did a report this year. It was the first ever report that came out in April of this year that talked about the state of machine identity management. And we surveyed over 1,100 people across 12 industries, two global regions, and we came out with some really, really good data around what's the state of this and how are we managing it in the enterprises today. So we're not going to mention every single thing in this report. If you want to get the report, you can go to keyfactor.com and download it. But a couple of things we want to highlight here and to get to at the end where we get to some practical steps where you can take control of your machine identity management problems today. So the first thing is you want to look at is what was driving the use of PKI and machine identity management, right? We talked about digital certificates. PKI is the backbone to generating that. But what were some of the things that are driving the use of machine identity management and PKI? Well, the first one is, if you look at just why is everything going this way, there's two main core reasons. One is cloud-based services. People are deploying more and more cloud infrastructure that's out there. And then the other one is a zero trust security strategy. So zero trust security strategy has usually been focused on, again, that human identity side. Now what we're looking at is if we're pushing more and more stuff into the cloud, we're going faster and faster and faster with deploying these machine identities, we also have to take a zero trust approach to managing these machine identities, just like we're doing the human identity side. So two of the main ones were this, remote workforce. That's obviously one that everyone has had to deal with these past 2 years. Internet things, DevOps, and mobile devices. But those two areas are huge. The cloud-based services, using cloud to accomplish a lot of your digital transformation that you're going on, and then just having this enterprise-wide zero trust strategy you have to start implementing a part of your organization. And again, all this kind of backs up more and more data we have, which is that 61% say they're deploying more cryptographic keys and digital certificates than they ever have before in their organization. So that's kind of what's spurring the push and the influx of more and more machine identities. What that's resulted in, though, is some challenges related to these identities. And the first one really relates to operational burden. Around 62% of respondents said that the growing use of keys in search has had an increase operational burden that they have on their team today. This is a huge thing because it really highlights a skills gap and also just a burden gap, or not necessarily a burden gap, but a burden that's placed on organizations today that may not have the skills to actually manage these cryptographic assets. The next one is, 55% said that they were concerned about the increase of risk of key or certificate misconfiguration. Lots of things happen. We'll give an example of a misuse of a certificate that was very public this past year. We'll talk through kind of what happened with that. But we also know that there's a burden that's placed on these people, and they don't really know how to solve these certificate-related outages, and they don't even know how to configure them properly because, again, it's not their specialty area. And the last one gets to visibility, which is they have no idea how many certificates or keys are actually in their organization today. And all this basically leads to certificate outages that are widespread. 88% of companies said they had at least one unplanned certificate outage in the past 24 months. Certificate outages aren't the only thing that can happen with this, but we'll get to and we'll get to some of the examples of this, how you can remedy those later on. But this is one of the big things that everyone kind of knows about. When there's a certificate outage, whether it's public or it's internal to your organization, everyone knows about it because you can't access things you could access 3 minutes ago. So it's a big thing that happens that disrupts businesses both internally and externally. If you're B2B or B2C, it doesn't really matter. We'll talk about an example of that in a few slides here. And then the other thing is just that on the horizon, there's this continual push to have these TLS and SSL certificates have shorter and shorter lifespans. Back in 2012, it was around 60 months that a certificate could actually live. Now we're down to 398 days for an expiration of a certificate. So that means that burden we just talked about, you're gonna have more burden, you have more misconfigurations you have, and if you have to renew all these certs faster and faster and faster to stay secure, if you don't know where they are, that's going to be a problem. So let's talk about what an example of this, of when an outage actually impacts your business. And we're going to use an example. We could use Microsoft Teams. We could have used a Spotify example, but we're going to use the Epic Games example. And I'll tell you why, because Epic Games had this outage, but they were extremely transparent about what happened to their customers, to their business, which I think is awesome. And everyone should use that model in the future. Whenever there is some type of problem that happens in security, we can always learn from it and get better at it. So let's talk about what happened. And credit to Epic Games to detailing exactly what happened. So the first thing that happened was at around 12 p.m. There's an outage. So a TLS certificate expired, and it basically halted traffic between all their backend systems. Around 12:12, so they were found it pretty quickly. They confirmed the certificate as a root cause, and then started the renewal process. So again, what's interesting about this too is that it took them about 12 minutes to figure out if it actually was a cert-related outage. They didn't even know if it was a cert-related outage to begin with. It could have been anything. The next thing was the certificate was like, okay, we found it. Let's start the renewal process. And within a minute or so, the certificate issued and started the rollout of the backend systems. They got on a call and they started to figure out all the people that were directly involved and kind of update them on what's going on. And then what happened was there was a surge rate that overwhelmed Epic Games and their launcher services. So within 46 minutes, they were able to find it and remediate the issue. But the problem was they didn't get to a full recovery until about 5:35 that night. And so this impacted their games launcher, their game store. It was only until 5 at night that they actually had this recovery. So around 4 to 5 hours, they had this problem and it affected their business. However, even though they were to get all this on back online and renew that cert pretty quickly, there had a bunch of effects that occurred even after they renewed the certificate. So kind of what happened was, if you look at some of the details they have here, was that they basically said, hey, listen, we weren't actively monitoring our certificate systems. That was a problem oversight by us. We're going to remedy that. We didn't have an automatic renewal in place to make sure it was renewed. And the wildcard cert that was used was also used across 100 different other production instances. And so what was going on was, even though that they fixed the certificate and they detailed what the problems they had, the problem they had was that they had this huge surge of requests that basically DDoS their entire system by their customers. So this influx of their own customers actually doing all these retry calls had a bigger effect. And it wasn't just related to, hey, this is the cert outage, we fixed it, and now we're good to go. That's a problem that they had to fix and had to deal with, but it impacted their business in a big way versus just quick, small downtime that they actually had. So that's a quick example. Again, credit to Epic Games actually having this laid out for us to take a look at. But let's look at like a little bit behind the scenes of why a lot of these challenges kind of crop up. The first one is that PKI deployments are getting more and more and more complex. Some people use wildcard certs to do a lot of things at the certificate level, but even outside of that, that creates a single point of failure that's not very good. But outside of that, what they're doing is they're integrating and using all different types of certificates from different areas. So, for example, they could have a privately rooted CA with EJB CA or Microsoft CA. They could be using built-in CAs, which are a part of Vault and Kubernetes. They could be using free CAs like Let's Encrypt and Zero SSL. They could be using public certificates like Entrust and Digicert. All these certificates that are out there used to protect your machine identities. There's a lot of these going on, and that creates a bunch of complexity. And the complexity basically leads to these 4 gaps, again, we've identified in the business today. And again, talked about a little bit mainly on SSL and TLS certificates, but this machine identity management gap spans all those cryptographic assets. So again, it goes back to companies not being able to have sufficient IT staff dedicated to PKI, gets back to SSL and TLS. Companies are still using spreadsheets to track the digital certificates they actually have. And that produces a problem with not being able to auto-renew. And then companies don't have an accurate inventory of not only their SSL and TLS certificates, but also SSH keys, secrets, cryptographic keys. All these things kind of come into play. And then the last one is that there's no formal policies and controls around code signing keys. So all these machine identity gaps are things that are real in businesses today, and they're things that we want to help you fix. So what now? So these are some things that anyone can take a look at, and they're good strategies, not only if you're starting out or if you're in the middle of your machine identity management focus today. You can still use these strategies whether you're starting from 0 or you're at a 5 on a scale of 1 to 5. So the first one is looking at establishing a crypto center of excellence. This one's really about building around a structured process where you can make sure you're following best practices. You can have you can create a team that's cross-departmental to actually help figure out what tools you should deploy for machine identity management. You can set up research and implementation. All these things go back to building a crypto center of excellence so that you can have more visibility to the exec team around how you're managing your machine identities for now and also into the future. Big thing about this part though is you have to get executive sponsorship. So making sure this is sponsored by the CISO or your head of cybersecurity. head of security and risk, whatever it is, make sure that you have this type of buy-in, because you're not going to be able just to build this up on your own. It's going to require a lot of cross-departmental collaboration between teams coming together. The next one is investing in machine identity management tool set. So we had talked about earlier that there's lots of these cryptographic assets that you have. Well, not every single tool is going to manage every single machine identity. There's things that do only certificate and lifecycle management, things that only do SSH key and certificate management. There's PAM, there's secrets management, KMS systems, all these things, managed PKI services. You need to look and see how this fits into your Crypto Center of Excellence plan, and it's not something you're just looking for a quick fix on. We always say you're not going to solve everything with tools, but they're definitely going to help out, right? So make sure that you're adding in the appropriate tools for the appropriate assets you need to manage. And the last two, one is around building around crypto agility into your incident response plans. So crypto agility is huge as we get into the quantum age, as we get into the shorter and shorter lifespan of certificates and keys. You want to make sure that not only are you quantum ready, but you're also agile enough to use cryptography in the correct way at the right time. And what I mean by that is, like, are you setting up key rotation practices? Are you setting up plans to migrate to different algorithms when certain algorithms get deprecated? Are you making sure that you're able to identify and replace any of the keys and certificates that could be related to a crypto library bug? Maybe you run SHA-1 and moving to SHA-2, and some of these things then get moved over, right? There's going to be another SHA probably out there in the future. So make sure that you're building in a crypto agility plan into your Crypto Center of Excellence plans. Then the last one is use managed crypto services to close the gap. So a lot of people, a lot of vendors out there, they have things like managed PKI services, or managed PKI services, PKI as a service, zero touch PKI, wherever you want to call it. A lot of these are kind of interchangeable, but this gets to, if you don't have the resources to manage your PKI internally, it's better just to outsource that, right? It's very complex technology, and if you don't have the dedicated PKI staff on hand, they're not going to be able to prevent a lot of the certificate related outages and audit failures that occur when you go into key and certificate misconfiguration and improper planning for PKI. So there you go. There's some quick ideas around how you can start managing and helping out in this machine identity management process. Next steps are do some more research around machine identity management if you haven't already. Gartner's got a lot of good stuff. Our Ponymun report from this year, go and take a look at that one. We'll be coming out with a new one in 2022. And then go to keyfactor.com to learn more about machine identity management and how that plays into your overall IAM strategy. Thanks.